Hello there guys, welcome back to another epic and extra maths video. In this video we're taking another look at the Weierstrass substitution, which is something that we can do in order to compute integrals that look like this. So essentially trig integrals tend to be fractions, and yeah, we can basically turn them into algebraic integrals using the following substitution. So t is tan x over 2. We can replace sine, cos and tan with these here. Link in the description to the video deriving all of these. I'm not going to derive those in this video. And also dx is always 2 over 1 plus t squared dt. Whenever you do the substitution, t equal tan x over 2, changing from x's into t's. So here's an example. Now look at this for a second. Can you think of a way to do this using a normal u substitution, the reverse chain rule, integration by parts, partial fractions, or any other integration method that you know? Well, maybe, maybe not. Personally, I can't think of one off the top of my head. So this is really powerful because we go from not being able to do the integral to being able to do the integral. It's not even just a new way of doing it. It's, can we do the integral? No. Well, now we can. Yes. So very good. So let's just go straight into this, guys. Let's rewrite the integral. First of all, we need to say that t is tan x over 2. And then we will rewrite the integral involving all of the stuff that we have here. So the integral of 1 over sine x plus tan x, and I'm going to call this I, as sometimes I do, just so I don't have to keep writing this integral out. The integral I is equal to the integral of 1 over sine x, which is 2t over 1 plus t squared, plus tan x, which is 2t over 1 minus t squared, dx, but dx is 2 over 1 plus t squared dt. Okay, again, looks like quite a bit of a mess, but we can simplify this and it will become quite nice. So first of all, let's times the numerators together, so just 2. And then let's do the denominators. The denominators are always the hard ones here. So 2t over 1 plus t squared times 1 plus t squared is just 2t. And then 2t over 1 minus t squared times 1 plus t squared, that's not really going to simplify very much. That's just going to be 2t times 1 plus t squared over still 1 minus t squared, and then that's just dt there. So still looks quite bad. Now, let's times the top and bottom of this main fraction by 1 minus t squared to make it look a little bit nicer. So now the numerator will be 2 times 1 minus t squared, and the denominator will be 2t times 1 minus t squared, plus 2t times 1 plus t squared. Like that. At least now we don't have any weird, gross fractions inside of other fractions. So now let's go ahead and simplify this as much as possible. So the numerator is going to become 2 minus 2t squared, and the denominator is going to become 2t minus 2t cubed plus 2t plus 2t cubed. Hopefully that makes sense. Okay, and then let's just keep going. First of all, I'm noticing every single term has a 2 in it, so let's just do that. First of all, let's cancel the 2t cubes out, because they cancel, and then every term that remains, I'm going to just divide it by 2, so everything will now be a 1. So I'm going to have the integral of 1 minus t squared divided by 2t plus 2t, that's 4t, but I divided it by 2, so divided by 2t dt. And guys, look at this. I mean, we're doing pretty well on the simplifying front. This is looking pretty straightforward. Okay, now there's a few different ways of doing this one. I would say, oh, I've done it again, guys. I've left the last video, all the working out on there. So I'll go and clean that in a second because I think we're going to need to use that board. I did that in the last video too. I'm a bit forgetful in that way. Okay, that's why I like maths, because you don't have to remember anything. Okay, now I'm going to factor out the 1/2 integral of 1 minus t squared just over t, but I'm then going to split the fraction up. So I'm going to rewrite this as 1 over t minus t squared over t, so just t dt, like that. And then obviously this is a very simple integral to do. So stick with me for 1 second. I'm going to rub off the whiteboard, or the blackboard I should say, underneath this, and we'll continue doing our working out. Okay guys, we're back with a fresh blackboard here. So continuing our working out from over there, we have that I, the integral that we're looking for, is equal to 1/2 times, the integral of 1 over t minus t with respect to t. So this is fairly straightforward, hopefully. Remember, 1 over t integrates to the natural log of t. So this is going to be the natural log of t. And I suppose technically we should have absolute value here as well. So absolute value, because 1 over t integrates to the absolute value of the natural, or so the natural log of the absolute value of t. Okay, and then minus t squared over 2 is what that will integrate to. T integrates to minus t squared over 2. Close bracket plus c. Okay, cool. And then guys, we're basically done. The last step is to, again, just replace t with what it is, tan of x over 2. And then we're done. So we have the integral, and I will now write it for what it is. Remember, the integral that we were actually doing to begin with is the integral of 1 over sine x plus tan x with respect to x. We've worked out that this is equal to 1/2 the natural log of tan x over 2. And then I'm expanding this out, so I have 1/2 times minus 1/2 minus 1/4 tan squared x over 2 plus c. And that's the final answer. The integral of 1 over sine x plus tan x with respect to x is 1/2 the natural log of the absolute value of tan x over 2 minus 1/4 tan squared x over 2 plus c. And as always, if you really want to, for whatever reason, you can replace, for example, the tan squared x over 2 with something else, or even just the tan x over 2. If you want to write it in terms of just x again, you can use the double angle formulae to do that if you really want. But I don't think there's any particular reason why you would. I think it's just fine. It's just chilling how it is. So anyways, guys, as always, thank you so much for watching. Stay tuned for more Weierstrass substitution videos, and I'll see you in the next one. Cheers.